All right, guys. Hey, welcome back. This is Piecewise Functions Part 2. Actually, there's going to be 3 parts to this. We have to evaluate piecewise. But there's 2 functions I want to talk about a little bit today that goes along with this. And that's what we're going to do, okay? So this won't be a long lesson, but still it's very important. So, looking at this, piecewise linear functions, okay? What do those look like? Well, this one contains a single expression. An example would be a step function. Now you're probably thinking, wait a minute. In the previous lesson, we were piecing together different functions to look at a creative looking graph, we'll call it. So how is a linear graph in pieces? Like, how does that work? Okay, well, let's take a look here. One type of step function is called the greatest integer function. Okay. So what this does, and we have a new notation here, okay, it's going to be these double brackets. Now when I first was introduced to something like this, it was in college, and we did ceiling and floor notation, okay? So for instance, if a number was like 3.2, you round up to 4. And if it was a floor notation, no matter what the number was, you always went to the lowest. That's what I learned. This is putting everything together in a way, which is pretty interesting. So this is saying that, okay, a step function is defined as the greatest integer less than or equal to x. Okay, so for instance, 3.25, okay, we want the integer that's less than or equal to x, so it's going to be 3. So you're not rounding in a way, you're just taking the number that's less or equal to x, just like the definition says. Hey, how about that? Now, for negative numbers, you got to be careful because we want less. So it looks like you're rounding it up, but you're not really. You're taking the integer that is less than that, which is negative 5. Okay? So new type of notation here, a little bit different than what you're probably accustomed to. So the real question becomes, why? Why even have this notation? When is this usable? Hey, here's an example that will show you. Okay? So psychology. Psychologist charges counseling sessions at a rate of $85 per hour and any fraction thereof. Draw a graph that represents the situation. So let's talk about this for a second. If you were in this session for 30 minutes, he's going to charge you $85, no matter what. If you're there for 59 minutes, still $85. An hour, $85. A minute or an hour and 1 minute. Okay, you now breached into $170 they're going to charge you because you're going into the second hour, okay? You didn't get a full second hour of counseling, but you dipped into it. So you're automatically charged $170. Does that make sense? So if I were to do a complete 2 hours, $170, 2 hours and 10 seconds, boom, you're getting paid triple it now, which would be what, $255, okay? So that's what this means by any fraction thereof, okay? So if you're going to get your money's worth, you might as well stay for that full hour, and only for that hour. Don't tip into the next one by a minute because you're going to get charged more, okay? So what we're going to do is we're going to create a table here just to see what this is going to look like graphic-wise. So from 0, including 1, you get charged $85. Between the first hour and the second hour, including if it actually hits the second hour, that's the equal to sign, you get charged $170. 2 to 3, you get charged this much. So notice something. The x's due incrementally. Did I say that right? Yeah, I think so. By 1. But look at the rate that they're being charged. Okay. It's doubling each time, right? Okay. So you're getting charged $85 for each one, but it's not linear in a sense of a line because that's a constant slope. As you add more time, you're getting charged more. But that's not the case here, right? It really isn't. So how are we going to do this? Well, here's my graph. So down below, I'm going to have the hours. 1, 2, 3, 4, 5, and 6. Actually, what? We just go to 5, so there we go. Apparently, this psychologist does a 5-hour session. Boy, wouldn't that be a lot of money? On here, we'll list the amounts: so 85, 170, 255, 340, 425. Now, if I didn't go, let's say I put 0 time in, are you getting charged? No. So I'm going to put an open circle there because we're not including that value. From here on out, if I start getting time, even if it's a minute, you're getting charged $85 all the way up to an hour. I'm going to put a closed circle there because I'm allowed to charge $85 when X is 1 or when you have 1 hour. So notice, see what this can't talk. See how this reads. If I put 30 in here, 0.3, 30 minutes. That's not right, it'd be a half. Sorry. If I put half in here, I'm getting charged $85, right? If I put in 50 minutes, which is right here, go up to the output, I'm getting charged $85. So you see how that's representing it. Now, when do you charge 170? Well, not at the hour mark. So I'm going to put an open circle there. I don't quite get charged that. But right after that hour, whether it's a second or more, I get charged 170 all the way up to 2 hours. See the importance of these dots now? Open means you're not charged. So at 1 hour, the closed dot says you get charged 85. The open dot says you don't get charged 170. As soon as I go past 1, then I'm getting charged 170 up to 2. Okay? And now you can kind of see the pattern here. So open, close, open, close, open, oops, open, close. Okay? And in fact, did I go over? I kind of did. It was hard to look off this side. So there's this guy, open, close. There we go. So this is my step function. See why they call it a step function? It's like a bunch of steps. All right. So this is what it looks like graphically. It's not, it can't be linear like this, like a line that we're used to, because once again, I'm not doing a constant charge as you increase your time. It's in increments, okay? And that's what this is showing. It's still classified as a linear function, but it's not in the case of what we're used to, okay? And I'll show you the PowerPoint here. Here's a clear picture of it. So as you can see, between this time frame, you're getting charged 85. Between this time frame, you're getting charged 170. The dots indicate where that time and that money period stops, okay? All right. Same situation, just different a little bit, different numbers, different context. So, okay, it's not the same. The daily grind charges $1.25 per pound of meat, or any fraction thereof. Draw a graph that represents the situation. So, I would pause the video so you can figure this out. C and D would be no bueno, okay? Looking at this guy here, we know it's not a linear trend based on the conversation we had on the previous problem. And we know it's not D because they haven't even filled out the rest of this yet. And it's not even proper. Like here, they're not even telling you when it's exactly $3. Okay, is it $3 or, I'm sorry, is it $2.50 if you get 3 pounds? It's very vague. So it's not, this is an incomplete graph. So these two are gone. So it comes down to A and B. And the correct answer is going to be A. Not because it just matches this, but the reason why B isn't the correct option, look at the dots, okay? This is saying if I get 0 pounds of meat, okay, I'm paying them $1.25. That's not right. If I didn't take anything, why am I getting charged, right? So that's why the dots are important here. Okay, so over here we switched it. If you didn't take anything, then you're not paying anything. That's what this tells you. Right after 0, though, now we have a solid line. Now you're going to get charged, right? Whether it's an ounce, 8 ounces, or a full pound, you're getting charged $1.25. Once you go over a pound, like a pound and 1 ounce, now you're getting charged $2.50. Okay? All right. Our last type of piecewise is an absolute value function. Now, you might think, well, how is this in pieces? It is. Look at it in terms of slopes, okay? This is a y equals x graph. But am I using the full graph of this? No, I'm only using this part of it. That's what this is stating. As x is greater than 0, you're plotting this. Okay? If I go down here, x is less than 0, and that's incorrect. So that's why I'm not plotting it. That's a restriction. If you plug 0 in, you get 0. So there's the second part of my graph. The last part of my graph is this guy, which is a negative sloped line. And I'm not graphing it here because I can only graph this guy when x is less than 0. So we talked about this before in the past. This is a V-shaped graph. Okay? Domain and range would be all real numbers for domain, all non-negative for real numbers because we don't go below the x-axis for that guy. But this could be treated as a piecewise, believe it or not. Okay? So let's try an example out with this. So here's our first problem. Okay? And I am going to erase this very carefully because I want to use it. I want to use this. There we go. Okay. I don't think that's too bad. So if we don't know what something looks like, we're going to plot x and y points. Okay? We know the gist of what absolute value looks like. It's a V-shaped graph. But how are we going to do it onto here with a plus 1? So we're going to observe a behavior. So -3, -2, -1, 0, 1, 2, 3. That's going to be the points I'm going to use. And then on the other side, I'm going to plug it in. Oops, sorry. That should be a plus 1. If I plug -3 into here, that becomes +3. Plus 1 gives me 4. If I plug a -2 in here, it becomes a +2. Plus 1's 3. This will be 2. This will be 1, 2, 3, and 4. You can kind of see the symmetry behind it, right? See how the values repeat? And that's the nature of the graph, right? If it's a V-shaped graph, you see those y values being used again, okay? We talked about different functions, right? 1 to 1, on to, and so forth. Now let's plot these. So at -3, 4, we have this guy. -2, 3, -1, 2, 0, 1, and then it just repeats on the other side. There we go. So there's what the graph looks like. Okay. So typically, the graph is on the origin, 0, 0, and it goes in both directions with a +1 slope and negative slope. Here, when I add the +1 on the outside of it, it shifted it up by 1, right? So we could say, with an education guess for right now, if I put a -1 there, that would probably shift it down by 1, right? Okay? We'll talk about transformations in the future. So my domain is still going to be all real numbers, right? Because once again, I'm not excluding an x value. Okay? My range, well, it's y values given that what? Y, is 0 going to be included on this? No. 1 is, 2 is, all the way to infinity. I don't have no negative y values, so y has to be greater than or equal to 1. That's my range for that. Okay? And what else? So now for our final one, and I encourage you, pause the video, okay, see what you can do. So which one of these equations will give this guy? Now, let's just think about this. We just discussed if I add 1 to this guy, it shifts it up. If I subtract 1 on the outside, I would assume that it would shift down, okay? So C doesn't have that, right? So C's gone. Now we have 1, 2, 3 options left. Okay. Well, it also shifted, right? See how the graph went over to the right? So that must mean that A is out of the options for us. So now we're down to B and D. Which one could it be? I didn't mean to rhyme. Well, easy way to do this, let's plug a point in. So this point is at 1, -1. So let's plug that into here. If I plug 1 in, I should get -1. Let's let's see. 1 minus 1 is 0. Absolute value of 0 is 0. Minus 1 is negative 1. So negative 1 equals negative 1. B is my correct answer. So B is that graph. Okay. If I plug 1 into here, see how 1 and 1 gives me 2? 2 minus 1 is 1. 1's not equal to negative 1. So this is not this graph. You could make another observation here, right? Don't you think? You could look at this and say, wait a minute, Mr. McCullough, if it's a subtracting 1 on the inside, it's moving it to the right by 1. So if it's a plus 1, I might see this actually go to the left by 1. Okay? And that's an observation. I mean, we're going to confirm this stuff in the future, but it's kind of just warming you up to it. All right? So that's it. That's the whole lesson. I'll put another lesson video out, part 3, which will be evaluating piecewise functions. Okay? But other than that, that's it. So hope you guys are doing well. Okay? Hopefully you're able to follow along with this. If you have any questions, please let me know. But until next time, have a good day.